has vertices and the lines are called edges. So the real life example could be three cities A, B and C. They are connected via three different roads, A to B, B to C and C to A. So I can represent them in the form of a graph where A, B, and C are vertices and AB, BC and AC are edges. Alright, simple? Now, let's move forward. There are different types of graphs here that I will quickly explain you. But before that, every vertex, vertices is a plural, vertex is a singular. Every vertex has something called a degree. Degree of a vertex is the number of edges connected to that vertex. So for example, degree of B, and I said DEG, B is there are two edges connected to it, and I said 2. Similarly, degree of C is 2 and degree of A is also 2. You can have something like this as well. This is called a loop. Loop is that edge which starts and ends at the same vertex. When you are counting the degree of a particular vertex which has a loop, you count that edge twice. So here, the degree of C is 4. 1, 2, 3 and 4. So your degree of C is 4. Alright? Any drama so far? Easy? Now, you could have multiple edges as well. You could have like this as well, where two vertices are connected by two edges directly. Alright? So this is an example of multiple edges, whereas this is an example of a loop. Now let's understand the types of graphs. Shall I take this off? Right? Now the first one is called a simple graph. A simple graph is that graph which has no loops, no multiple edges. That's called simple graph. But this graph is not simple. It has a loop as well and it has multiple edges as well. Right? Then there is something called an isolated vertex. So for example, if you have this graph A, B, C and you got a vertex D here, which is not connected to the graph itself. So you call that graph as isolated vertex. All good? Then you have something called degenerated graphs. Degenerated graphs are those graphs which has no edge at all, no edges, just the vertices. I'll say A, I'll say B, I'll say C. They're not connected at all. Then there is something called connected graph. Connected graphs are those graphs where you can reach from one vertex to the other either directly or indirectly. So this is a connected graph. Or probably if suppose I had this, it's a connected graph. There is no isolated vertices in the connected graph. I can go from B to D, I can go from anywhere to anywhere, either directly or indirectly. So they are called connected graphs. Then you have something called complete graphs. Complete graphs. Now, complete graphs are those graphs where you can reach from one vertex to the other directly. Directly, for example, A, B, C. Complete graphs are also connected graphs, right? Because connected graphs are you can reach anywhere to anywhere, n number of hops. And connected graphs are, so I mean, just like a puzzle, right? You can go here, go here, go here. This is D. You see, this is a connected graph now. Right? You can go from anywhere to anywhere, one hop. And this is connected graph as well. So this is a complete graph. However, if I take one edge off, this is not complete graph, this is still a connected graph. You can go from A to D in 2 hops. All good so far? Then there is something called bridges. In this graph here, take this off. In this graph here, this is a bridge. Which means if I take this off, I cannot reach the other end of the graph. And let's say if this would have happened to be another graph like this, D, E, F, then CD is a bridge, which eventually, if taken off, you land up into 2 different graphs. Right? So that's called the bridge. Then there could be subgraphs. Subgraph is when I extract a graph from another graph. So let's say I extract this bit, A, B, and C out of this. I've extracted that, I maintained the connections as per the original graph, and I created another subgraph. So that's called the subgraph, right? Any questions so far? Take this off and we'll talk about the isomorphic graphs. Isomorphic graphs, or I can also call them as equivalent graphs. Now let's say I tell you that you have 3 vertices, you have 4 vertices, A, B, C, and D, where you have a connection from A to B, you have a connection from B to D, you have a connection from C to B, and you have a connection from A to, let's say we've got these connections. And I say, let's draw this graph. Can you try drawing this graph? I need 4 vertices and 3 edges. Please draw this graph. Try that.
The vertices, the lines.
Sorry?
All the vertices, the lines.
Yeah. All the vertices?
Vertices, the lines.
Your choice, wherever you want to place. Draw a graph. Take any four vertices. I can take A, B, C, D. I can take A, B, C, D. I can take A, B, C, D. Your choice. Where you want to take it. Quickly draw a graph, please. And I'm drawing mine. So I'll say probably A, B. That's my choice. A to B, B to B, C to B. I've drawn mine. Have you drawn yours? Now, one thing that you would notice is, and if you look at your partner's sort of notebooks, they're all different shapes, right? But then the connections are still the same. These graphs, where shape does not matter, but connections still remain the same, are called isomorphic graphs or equivalent graphs. I could have drawn it like this: A, B, C, D, and I say A, B, C, D, and I say A to B, and then B to B, and then D to C. That's another graph. So these two graphs are exactly the same. Shape does not matter. So they are called isomorphic graphs. All good so far with me? All right. Then we talk about something called planar graphs. Planar graphs are those graphs where the edges don't overlap. So for example, I say you've got this graph here. A, B, C, D. Here what you'll see is AB is overlapping with BC, it's cutting, right? This is not a planar graph. Planar graph means you have very clear faces, you've got very clear planes in it. So how do I make this graph? I can do it like this. Yes, they are isomorphic, right? So now you've maintained the connection, but you've avoided the intersection of the lines. And you've made this as a planar graph. Make sense? Right? Simple, right? Very easy. Alright. Then there's something called, I'll take this off, this is called Euler's formula. Take a note of what I'm just telling you, because I'll make you do a question which will have all of that together. Then you've got something called Euler's formula. Euler formula says V plus F minus E equals to 2. Or you can also, a few books, until last year they used to write it like this. I don't know what on earth came into their mind. They've started to write it like this. They changed the algebra of it. I don't know why. Stupid. I'm used to this or whatever, because if you take E here, it becomes this formula. Right? So don't get surprised if you hear this. Most of the teachers who are used to teaching the old syllabus will still teach this. Doesn't really matter on that. Now Euler's formula tells us V are the number of vertices. F is the number of faces or the planes, and E is the number of edges. Let's take an example. Let's say that's the graph. How many vertices do I have here? 3. How many edges do I have here? How many faces do I have here? Faces are the planes. So first the inside face. So that's the face 1. And there's also the rest of the world is also a face. Face 2. So there are 2 faces. Plug this in, we'll see what you get. See what you get. Is this fitting in? V plus F minus E equals to, you see, 2, no? So you proved Euler's formula. Now how your questions can come in is you will be given a graph, you will be asked that, okay, there are 3 vertices, 3 edges, how many faces the graph has, so on and so forth. That's very easy questions, right? Alright. If that makes sense to you guys, let's now jump on and do a few questions. And we'll go from there. Let's do question number 10 on chapter 13a. Question number 10, please. Exam style. All right. So, it's a planar graph. Once you've made it, it's a planar graph, right? Yes? What else? It says the graph contains a bridge. I can't see any. I can't see any. Right? So this is how a graph's going to look like, right? This is how it's going to be. Yes? Correct? Roughly. But there's no bridge. Correct? So choice number B is also false. The third says, is it a simple graph? What is a simple graph? A graph which has no loops or no multiple edges. These are multiple edges. False. This is not a simple graph. Next one. The sum of the degrees of the vertices is 16. Let's try that. Sum of the vertices of the degrees. Sum of the degrees of the vertex. So you can try that. This is A, let's say A, B. What's the degree here? Yep. What's the degree here?
2.
What's the degree here? What's the degree here?
2.
Is it 14, is it? Have I missed any connection? Or drawn it incorrectly? Sorry. My graph's incorrect. So this is a triangle on the top. And this like this, right? And this is how I'm going to make it, right? That's the graph, right? Degree here is how much? 1, 2, 3, 4. Degree here is how much? 1, 2, 3. Degree here is how much? 1, 2, 3. Degree here is how much? 1, 2. Degree here is how much? 1, 2, 3, 4. Can you add that? 16. So that means B is, this statement is correct. And the last one says it's a complete graph. Complete graph. Do I have a connection from here to here? Can I go anywhere to anywhere? Can I go from here to here directly? No, false. Right? So this is how you have to apply the very basics of graph theory, and this is where it will trick you, right, and test your understanding. So there are only two statements which are true, and that comes to